What if, tonight, the sun quietly launched a storm at Earth? No fireballs, no shockwaves, just invisible energy that can shake our power grids, hit satellites, and light up the sky with auroras. Right now, that's not science fiction. NOAA, the U.S. National Oceanic and Atmospheric Administration, has issued an alert. A powerful geomagnetic storm and a severe solar radiation storm are hitting Earth's space environment. These disturbances began on the 20th and are expected to last into the 21st. So while you're watching this video, Earth's magnetic shield is actively being bombarded by the sun. On the 18th, the sun unleashed a major solar flare along with a coronal mass ejection, or CME. The flare is a flash of radiation. The CME is a huge cloud of plasma and twisted magnetic field. The flare sent high-energy particles racing toward Earth at almost the speed of light. They arrived within minutes, triggering an S4 level solar radiation storm. Severe on NOAA's 5-step scale. Hours later, the slower, heavier CME slammed into Earth's magnetic field. As this cloud of charged particles collided with our magnetosphere, geomagnetic activity spiked sharply around the globe. At 2:38 p.m. Eastern Time on the 19th, the geomagnetic storm first reached G4, a severe level on NOAA's scale. Then, at 3:23 a.m. on the 20th, it climbed to G4 again. So what do these letters mean? NOAA ranks solar radiation storms from S1 to S5, and geomagnetic storms from G1 to G5. Higher numbers mean stronger, more dangerous space weather. For radiation storms, the scale is S1 minor, S2 moderate, S3 strong, S4 severe, S5 extreme. Right now we're at S4, one step below the top. For geomagnetic storms, NOAA uses G1 to G5. G1 minor, G2 moderate, G3 strong, G4 severe, G5 extreme. This event has already hit G4 twice. According to NOAA, this is the strongest geomagnetic activity recorded since October 2003, the era of the famous Halloween storms that disrupted satellites and power systems around the world. So what can a G4 storm actually do? In high-latitude regions, electric power grids can see voltage swings. Operators may face alarms and extra load, and in extreme cases, parts of the grid can become unstable. Satellites are also in trouble. Their attitude control systems can behave strangely, making pointing less accurate. Low Earth orbit satellites feel extra drag from an expanded atmosphere, slowly pulling their orbits down. Radio communication takes a hit too. High frequency, or HF, radio in polar and high latitude regions can weaken, fade, or cut out completely, affecting aviation, shipping, and polar research bases. But there is a spectacular upside. Strong geomagnetic storms supercharge auroras, pushing them far from the poles. During this event, people in U.S. states like New York, Wisconsin, and Washington may see the northern lights. Meanwhile, the S4 level solar radiation storm is still ongoing, and satellite data show its intensity is still rising. S4 events are rare, and this one has already exceeded the 2003 radiation levels. On the ground, you're safe. Earth's atmosphere blocks most of this radiation, but astronauts, especially outside strong magnetic protection, face higher doses, so space agencies closely track their exposure. Airline crews can be affected too. Flights that cross the polar regions see increased radiation levels, so airlines sometimes reroute them. Satellites in geosynchronous orbit and launch vehicles face higher risk of electronic glitches. In the polar caps, over-the-horizon HF communication can be hit hard. Signals may distort badly or vanish for hours, affecting long-range radio links, military operations, and polar flights. Events like this remind us Earth lives inside the sun's extended atmosphere. When the sun's magnetic fields snap and erupt, the first things to feel it are our power grids, satellites, and navigation systems. In the next part of this video, we'll look at the solar cycle driving these storms, how close we are to a worst-case G5 or S5 scenario, and what a modern Carrington-level event might do. Because the scariest thing about a solar storm, like, this isn't just what it does to our technology, it's how easily it can happen. While most of us have no idea, the sun just fired a warning shot.